Welcome friends to my YouTube channel Java Nous. This is the second video on the solid design principles. So on first video, I already have talked about single responsibility principle. So if you are interested in that too, you can go back and watch my first video on this series. Let's start uh, today's topic, that is open closed principle. So as its definition says, software entities can be classes, method, modules, etc. The software entities should be open for extension but closed for modifications. In other words, we can say that we should design our software components in such a way where we can easily add new features without having to modify core component. Okay. So what it tries to say is, suppose you written a business logic, okay, for anything, and that is your core component, okay, and in future you want to add something on that. So that addition of new feature should be accomplished without making the changes in the core component that you have written, okay. So it may sound bit difficult to understand, but let's discuss it. Let's see an example, and I'm sure that after watching that example, you should be or you must be able to understand that the whole concept of open close principle. Okay, so let's open Clips. So see, suppose you have a requirement, means suppose you are working on a banking domain, and then you are writing a class called account, and this account class, the main requirement is return earned interest. Okay, this class should be able to return earned interest based on the account type. So there are different ways we can write our logic. There are different ways. Always, when you work on a real time project, there can be multiple ways of doing one thing. Okay, so we'll see the solution in two different ways. Okay, first way that doesn't follow the open close principle, and then we will see the second way where we will be following the open close principle. And through those examples, we will try to understand what is open close principle. Okay. So this is our requirement. Okay. And we have created a class called account, and there can be lots of different variables over here. But what we need in this requirement is uh, private double balance. So based of to calculate interest, we should know our balance in the account, right? And also we should know the account number and the interest rate. So let's create another variable called account number. Yep. And there can be many more other variables that we are not going to talk about now. Certificates. Okay. Now let's write the logic to calculate the interest earned. So we write a method called public double calculate interest. And The logic would be, this is the first approach, okay? First approach. This doesn't follow open close principle. So we can write it something like, using if condition, we can check if the account type is saving account number dot start with 1. So we are assuming that if account number starts with 001, we are considering it as saving account here, okay? Saving account. And on saving account, suppose we are getting returning 5% of interest rate. So the logic would be something like return balance into 0.05. Okay. Similarly, we need to write logic for other account types. Account start with 002, then consider it as current account. And then for current account, suppose we are giving 2% of interest rate. Okay, and then suppose currently in beginning we are just considering these two account types, current and saving. Okay. Yes, return 0. Okay. So this is the first approach. So this logic actually it's fulfilling the requirement, right? The requirement that it should return earned interest based on the account type. So this method is returning the interest earned based on the account type. It's fulfilling the requirement. This is the first approach. Okay. Now let's try to implement the same thing using another, second approach. Okay. And then we will compare which one is the better approach, okay, and all. So in second approach, what we will be doing is we will create an interface for this. We'll move this piece of logic, the calculate interest logic, interest calculation logic into a separate class or interface. Okay, so let's create an interface. This is called interest calculator. Okay, and then should have an abstract method like this, double calculate interest, and it takes balance as its input. Okay, and then we will have implementation classes for this interface. So first class is saving interest calculator. We have two different types of account currently, right? First is saving and another is current. So this class will implement what interest calculator interface. Okay, and then we will override the method that is coming from the interface. Okay, so in this class This method is returning this 5%, right? So just go ahead and copy this piece of code there. Remove it. Okay. So this is for like double. The problem here is not implementing right. Calculate interest double balance. Okay. Every class having implement calculator or calculator. It's over. I know it's being added. Yes, so see this we have created implemented one class that implements this interest calculator interface, and we have overridden the method that is coming from this interface. So saving account, we were returning 5% of interest rate, right? So same piece of logic we have copied here. Similarly, we need to create another implementation class for current account. So just copy this the same class and paste it in the same package. We name it as current. Okay. So open the new class. See, is we created another class that implements the same interface, and here we will be returning 2% of interest. Okay. So see, we have added three new components. First is this interface. This interface is having one abstract method, that is calculate interface, that takes balance as its input. And then we created two implementations, saving interest calculator and current interest calculator. So now this is the first approach. Now what you can do is second approach. Let's write the second approach. So you will copy the same method. Okay. Okay. And then you copy the, for now we will copy, just comment out this piece of code, otherwise it will give you, or say I rename it as 1. Now it will not give you error. Okay. Calculate interest 1. I will rename the method. And you need to have a reference of this interface into your class. So private interface calculator, interest calculator. Okay. And through this interest calculator, you will call the calculate interest method. Okay. So this is the second approach. Okay. This is the first approach. This is the second approach. The both are doing the same thing. This method also gives you the same result as this method is giving you. So based on the account type, it will give you the interest earned. But suppose in future you got a new requirement. So it's an extension. New requirements means it's an extension to the existing one, right? So the extension is now you need to handle fixed deposit as well. So currently we were handling only two account types, right? Saving and current account. Now client, after when you deployed this piece of code into prod, after a few months, client back to you and said that we need to handle fixed deposit as well. So what you will do? In first approach, suppose the first approach was deployed in the production. So what you will do, you will come here. This is the core component, right? In this approach, this is the core component. This is the logic that is doing your requirement, that is fulfilling your requirement, right? So this is your core component. And in second approach, this is our core component, right? So you got an extension, and to implement or to achieve that extension, in first approach, you are forced to make changes in the core component. You will have to make changes here, otherwise you won't be able to adopt the new extension, right? And what we learned when we were seeing that slide, what it says that uh, where we should design our software component in such a way where we can easily add new features without having to modify core component. We should not be compelled or forced to make modifications in our core component. But in first approach, when we got the new extension, we are forced to make the changes in the core component. So what you will do? You will do something like this, right? To adopt the new change or new extension, you will come here and you will add this kind of logic again. One more else if, right? And you will say when the account number starts with 003, it's fixed deposit. Okay. And then for this, you are returning says 7%. So now you adopted the changes, but to adopt that change, you had to make changes into your core component, and that is not allowed in open closed principle. So this particular approach, the first approach, is not following the open closed principle. And what is the drawback? When you make changes in the core component, it is error prone. So for this example, this particular use case is a simple one, right? I just written a simple method. So the chances of making mistake is less over here, but in real time projects, you write complex logics, and when you come back to your core component again and again to make changes for extensions, there is a chance that you can break existing piece of code or logic. Okay. And when you make the change into your core component, you need to go back and you need to make change in your, so you must be writing some in unit test cases for this method, right? So you need to go back to that unit test, you need to make changes over there also. Okay. So that kind of difficulties means this piece of code is not maintainable, not easy to understand. See, it seems quite complex. It's not user friendly. It's difficult to read and understand, right? And this is difficult to maintain also, because this is not following the approach one is not following the open close principle. Now let's adopt the extension, this extension into the second approach. We adopted that into the first approach. Now adopt the same change into the second approach. In second approach, this is your core component, right? But to adopt that change, you need not to come here and make any modifications. See how we can achieve that. What we need to do, we can simply we need to implement one more class for that interface that we have written. Okay. So let's copy the existing interface, paste it, and it is what? FD interest calculator. Say FD interest calculator. Okay. And open that class. See FD, we added one more implementation for the interface, this interface, interest calculator. And you need to return here the whatever interest that it's returning, 7%. Okay. That's it. Your requirement is done. You adopted the new extension without making changes into your core component. This is your core component. You did not do any change in your core component and you adopted the extension. Now you need not to make any changes in your unit test case. The extension was easy to do. You just written a class, an independent class, and your requirement is done. So the chances of breaking anything existing is very, very less. Okay. And this looks pretty, this is readable, this is maintainable, all these benefits with come with this approach, second approach. So this approach is following open close principle, and this is not following open close principle. Okay. So that's it, friend. I think that explains everything about this open close principle. So in next video, we'll be talking about the remaining principles, Lisco substitution principle and interface segregation, dependency inversion, etc. So please bear with me and watch my coming videos. I'll be uploading them soon. And if you like my video, please click on the like button and subscribe my channels. And if you have any suggestions for me, please do comment your suggestions so that I can make the future videos more interesting for you. Thanks for your time. Thank you very much. Bye bye.